never dies. Kicker unmasked, live it loud. Break the silence, join the crowd. Rock the planet, feel the fire. Shake the world, lift it higher. Whoa! Wires twist like veins of steel. Born to crush, born to feel. Lightning runs through every chord. Power surge, the final word. Shatter chains with sonic waves. Carve the air like razor blades. No escape, no retreat. Victory tastes so sweet. Kicker unmasked, live it loud. Break the silence, join the crowd. Rock the planet, feel the fire. Shake the world, lift it higher. Hey, yeah.
Good evening, ladies and gentlemen, boys and girls. It is so good to be back. I have been out of this seat for quite a few weeks, maybe even months now, and of course Jacob's been doing a great job. Ernie, I saw Ernie did a great job. He hates being on camera, but he did great just the same. But it is so nice to be here with you guys and girls again tonight. And before we get started, I want to let you know that we have a very special guest. You probably saw him in the teaser, Mr. Joe Hobart. Joe is one of our fan favorites because we love Joe. He's very smart, but he knows how to talk to regular people like me, so that's very helpful. So he's in the green room right now getting a massage. We had a nice steak dinner, so we'll bring him in just a moment. But I do want to say hello. Hey, Ernie, can you pull up the feed here? I can't see any of the peeps that have come in. I can't talk to anybody. I can't see who's here. So I don't even know who's here. Maybe nobody's here, which would be really weird. So, Ernie, what do we got? Oh, you guys like my t-shirt? I was not in town for this event, but man, did I hear about it. And I was watching the social media and it looked fantastic. If you were here, put some comments in. Tell us what you thought about the show. I'm sure you all had a great time because I heard excellent reviews. Actually, Bill Frog, who lives here in town still, he was at the show. He and I had coffee a couple of nights ago and he said he had a great time. He had great feedback about the event. So hopefully next year, assuming we're going to have one next year, I'll be able to participate and attend with you folks. So let's see, Bobby Burkett, of course, Bobby, hello. Hello, Aaron and Joe, Kicker. Nick Diesel, what's up, family? It is so good to see you, Nick. Who was here first? Was Bobby first? What time did Bobby click in tonight? Bobby, 4 o'clock. Good job, Bobby, 4 o'clock. That's good timing. Let's see, Nick, Solo X18, putting a box. Well, yeah, although I have seen some guys trying to do some aperiodic stuff with the Solo X's. In fact, our good friend Brian Gary is doing 4 Solo X8s in a infinite baffle free air installation in his Mustang. That'll be pretty cool to check out. Who else we got in here tonight? Christopher Austin, good evening. Hello from hot central Florida. Yeah. So I was in Indonesia on my vacation, a little family vacation. We also had a wedding to go to. Talk about hot and steamy. It is always hot and steamy. In fact, Mr. Joe Hobart was at my wedding in Jakarta 11 years ago, and he loved it. Right, Joe? Joe loved Jakarta. Just kidding. I'll let Joe tell the story. Mr. EE100, morning from Thailand. Thailand? Well, we were nearby. We were neighbors with Thailand, but we didn't actually get over to Thailand. But I do have a couple of pictures I want to share with you guys from my vacation. So tonight we have Stephen Bambro. He is manning the cameras. And of course, he also brought us dinner. So thank you, Stephen. Stephen is the man that can do just about anything except tell a funny joke. Right, Stephen? But he can draw a great joke. And of course, Ernie is back there working his magic to make us all look good. Colin with a C has colonized the booth back there. Hey, Brian. So we got all those guys in the house. JW is being a dance dad tonight. He's got a very busy week with his daughter doing some dance. So JW, I know you're not watching, but good evening and have fun being a dance dad this week. That is tough work. So we are going to take a short break. We're going to bring Mr. Joe Hobart onto the stage, and we're going to talk about amplifier development. From concept to completion, what does it take to make a Warhorse, an LX, a PXA, a CX, all of these great products? What does it take to make one of them? So we're going to go deep dive with that with Mr. Joe Hobart. So we'll be right back in about 60 seconds.
For more than 50 years, Kicker has been rocking the planet on anything that moves. Kicker, the legacy continues.
Something about your hands on the wheel, got a sexy touch. It's enough to make me and my Chevy blush. So long. Take it all off of that highway. Turn me on, I'll let you drive, baby. You can take it fast as you want to. Girl, little dirty looks damn good on you. Start me up, Stones on the radio. Girl, I love it when you let go. Don't waste your way in the wrong way. Get off on some 4x4 play.
Welcome back, friends, and welcome, Mr. Joe Hobart.
Thank you, sir. Glad to be here.
Joe,
Hope
did
everybody's
you-
having a good night.
Did you love Jakarta?
I loved Jakarta. It was the best place I've been to.
He's being polite. Well, we're not here to talk about Jakarta, although a little bit later I'm going to show you some pictures. But we want to talk to Joe about Kicker amplifiers. Now, you guys know we talk a lot about amplifiers, and we strive for the best quality at the best price point, which equals the best value. And how do you make a world-class amplifier that is virtually bulletproof, reliable, sounds great, makes rated power, and doesn't break? So how do we do that, Joe?
Well, that's a long process.
Give us the 30-minute version.
Well, typically, right, we have kind of two methods. Our tried and true product, right, the stuff that is the core, and we know where it's going to go, we know the development path. That product starts, as we have a list, as we'll show you here in a minute, of like how the process goes. You guys will completely ignore it. We'll make it short here. If Aaron can pull that up.
Yeah, I'll pull it up. Hey, Ernie, let's pull up Joe's process just to bore the audience for a minute.
Yeah, we'll give you a quick overview of how bad this is when we actually do this, right?
That wasn't it. Hold on, I gotta get this. Okay,
Yeah, you're up.
pull this up.
So there are three phases to our development process. There's pre-development, where the idea comes in, whether from internal or external, doesn't matter. We go through, we look at, can it be done? Should it be done? What makes sense to do it? And this is all in that process, the pre-one you just saw there. In there, we will make what we call a product development document. And in that, we will define everything from power to physical size to expected cost, materials to be made with, so aluminum, anodized, powder coated, casted, all the different options, right? Everything from the mechanical overall look all the way down to the technology that's inside of it, right? Is it DSP based? Is it analog based? Is it Class D? Is it AB? Is it G? Is it H? Like, what are we doing, right? Once that's done, then we create test documents. So all that has to be done in the pre. Then there's a stage gate. Basically, the product development team upstairs, which I'm part of, we take the expected costs, the expected development costs, the expected tooling costs, testing costs, all the things, put it all together, expected sales, pitch it up to that group, right?
At what point does feature creep come in?
Normally after this, unfortunately.
Oh, okay.
So it will end up in PPT, and if it gets a go, then it goes into actual development, which we have a whole other page and a cycle of loops to take you through the different design stages, which we'll talk about as we go through here.
Ernie, pop that up real quick, please.
So as you can see, there's two places there. If you can actually read it, it shows a circle, right? We get to a stage, is everything good? We'll circle back, start over, circle back, start over. That is how you get through our design stages. And in a typical product, you'll have what we call EV, which is engineering validation. You'll have DV rounds, which is design validation. Normally in that case, you'll have a a heat sink or something already, so it'll be what we call off tool. So that means the industrial design's been done and we know what it looks like and we've tooled something. And then you get to PV, which is product validation, right? We're getting really close to production. We'll then run a PP run, which is pre-production, make sure that the production line is smooth, efficient, works the way that it should.
And that's when you guys have to go to Asia.
That's when we're wherever at the whatever factory it is, wherever, if we're building plastics here at Neato, wherever, right? We'll be there for that run because we need to make sure we get it right then.
So I have to interrupt you because this is really an important part of the Kicker development. How many times a year are you and your team visiting factories?
There's usually 2 different groups of us that go because of the amount of projects we have.
Yeah.
So there's about 6 trips a year with 2 to 4 people depending on the trip.
That's a lot.
Yeah.
So you guys are living in airplanes and airports a couple months of the year.
Yeah.
Yeah, okay.
Yeah.
That's important because a lot of our competitors don't do any of that.
Yeah.
And I like to point this out. Of course, we're never going to name names, but it's good to understand that part of our development is these guys going to the factories to make sure it's happening the way we need it to happen.
Right, yeah. Keeping the quality control up, making sure the production line is correct. Yeah, it's a lot of the work. In general, I mean, to give you an idea, I've been here 18 years now.
Wow.
I've spent 6 or more years of my life in another country somewhere. Right? So, yeah, it adds up after a while.
Wow, you have a very forgiving wife.
Yes, yes, I do. It adds up after a while, but yes. So we get to the product planning team, right? Yay or nay. If it gets a yes, it goes into this main development path, and we start out with EV. In the EV stage, if it's a tried and true type of product, like say we're making another amplifier that's a lot like CX, and there's not too many unknowns, right? Like we know how to make something that size, we know how to make something that power.
Yep.
We will literally jump right into making a PCB that should fit the form factor that we want to do.
What's a PCB?
That is basically this board here, right? It's where you lay out your traces, your connectors, all your pins. Everything will be on that. Every PCB is different. Every PCB is a different size. And in this case, this is actually a remote control that we make for the OE world, for the GM tailgate.
Yeah.
This is the original prototype PCB of that. So to give you an idea in this case, this was the original one, which all these are test points, so we can validate every circuit, every last little thing. So we've got hundreds and hundreds of test points on here. But in the end, this product is this, right?
Yeah.
So we start out big in most cases and then shrink it when there's a lot of unknowns. In this case, there was a ton of unknowns. We had to make our own USB stack from scratch. So normally...
That's coding, right?
That's software. So
Software,
normally USB stuff that you guys interact with, like on your computer,
right,
a human interface or whatever it's using, that code is all pre-stacked on a chip. Well, years ago, that became illegal to import and export.
Ah.
So because this had to have an on-the-go to play a USB thumb drive music player, we had to create our own from the scratch.
Okay.
That was almost 1.5 years of software coding to make that happen, right?
Thank you, Ian.
Yeah, so that was a lot of work. Actually, thank you, Austin.
Oh, Austin. Thank you, Austin.
Austin did that. So we started out with something with a lot of test points, a lot of ability to jump and change and move because we really didn't know what the answer was yet, right?
Yeah.
And then in the end, we came with this nice small product. In the case of like a CX amp or a LX amp, KX amp, stuff that we make in a core everyday type of thing, we know these things, right? We've done this. There's not too many unknowns, no matter what the feature set is. There's some unknowns, but not a ton, right? Like 80% of it's known. In those cases, we jump right into making a PCB that is intended to fit in the housing, so hopefully we can have less sample rounds, right, to get to the end product. In this case, what I've brought here to show is an LX. This is the LX7 channel, and this is one of the very first EV rounds. You'll notice it's sitting in a cut-off KX heatsink.
Oh, yeah, yeah.
It has no connectors yet except for the power and ground, which were stole from a KX again and parted apart. The speaker connectors didn't exist. And, you know, this is how most of our development looks, right? You're trying to get something into an original size package that you don't have to change too much once you get it working.
What's this?
That's what?
What's this?
No, that means lots of power.
Lots of power. little dumbbell there.
Little dumbbell
huh?
there,
A
yeah.
dumbbell.
And so for our core product, that's kind of what early ones look like, because we already know how Class D works. We know how to make a Class D switcher. We know how to make a power supply. We're very good at that stuff. So there's still stuff with the layout that you have to fix, because the layout is 40% of what makes an amplifier good or bad is the layout, right? Not the parts. So there's still massaging and adjusting and going through samples. But in this case, the first samples will be pretty close to the right size.
Mm-hmm.
But in the case of like this, right, the first sample is
Massive.
huge, because we didn't care about package. We cared about, can we make all this stuff work?
Yeah. Now, when you shrink that big thing down to this, obviously you're reducing the real estate. So now you have to be concerned about the components making noise and crosstalk.
Yeah, so
and
layout
all that.
becomes very important. When you have a layout like this, like layout is a little more not important, right? You got plenty of room.
Yeah,
You're not
yeah.
jumping traces. You're not using vias to go through the PCB or anything like that. When you get to something like that, that's actually 3 PCBs in there, and it actually fits in this small back part here inside of that. So the PCB is only like 1 inch tall by 3 inches wide in the end, right?
Yeah.
So yes, and because all this stuff, something that we do that we know a lot of others don't, is we go through FCC, CTIC, CISPR 23. Like we do a bunch of radiated noise testing, EMC testing, because we do sell internationally and worldwide.
Sure,
Right?
sure.
So there's a lot of extra testing involved, and when you do that, radiated noise becomes a big problem. You really need to work on that.
So speaking of radiated noise, during COVID, we stashed a lot of money in the bank, and then we decided, hey, let's spend some of that, and we built some new labs.
We did.
And one of those labs is for what exactly?
EMC, so that is for us radiating noise, right? So back in the days, I'm old enough, right? First Class D car audio amplifiers came out. Everybody's excited. They're half the size of the other ones and cheaper. We grab them, we throw them in the back of the Taurus, and all of a sudden you have zero radio. And you're like, your guy comes back and goes, I don't have a radio. And you're like, well, you got a CD player, don't worry about it. Right? That's radiated noise, right? So that process over the years has, Class D amps have gotten better because they're switching faster. So they're farther away from the radio frequency in general, unless they're a sub amp. Some of those can be low enough. But the problem then becomes now is we have cellular, we have Wi-Fi, we have LiDAR. Like all this stuff operates in that higher frequency where we're playing with,
Switching,
right?
yeah.
So radiated noise is very, very important. So we've built a 3-meter lab over here, invested a bunch of money in equipment. We're getting ready to put up dampening materials all the way around, and it'll finally be ready to go. Thank you, Steve Irby, very much. That is very helpful to be able to look at that stuff early and not wait till later and have to send it off and wait for it to get back. A lot of radiated testing labs can be out 30, 60 days, and when you're trying to work on a timeline just to get the first test done and then have to make changes, every time you do it can take quite a bit of time, right?
So for clarification, this amplifier has to be put in that chamber, and what are we testing for exactly?
So we're testing for how much noise we radiate and conduct.
Electrical
noise. There's two things, right?
Okay.
So radiated noise is in the air. So the room is shielded. Like if you walk in it and close the door, your cell phone doesn't work, right? You have no connection. And then you turn the amplifier on, you play a tone through it. There's a whole setup where the cables have to go exactly the right way. Amplifier is set exactly the right way. And you run sweeps. And you look at the sweeps, and depending on how many dB of noise you're making, you either pass or fail depending on the standard that you're testing to. Everyone's a little bit different for every country, but they all have their own standards, right? That's the first test.
And we do that here before we send it to a lab where we pay for it.
Yeah, because no matter what, to get the actual certs in the end for
Yes.
the countries, you have to send it off to an accredited lab.
Okay.
So we do that here first so we know if we have a good chance of passing or not.
Yeah.
And if we think we're not going to pass, then we'll make modifications to the board, the output, whatever it needs to be, right? Run it again until the noise is low enough, and off we go. The secondary thing that you test for is called conducted noise. And that is what happens when it comes out your power terminals, right?
Okay.
So we all think of DC power as 12 volts and ground, that's it.
Right.
But the reality is as you draw current, 12 volts goes like this and bounces, and ground lifts and bounces, right? So when that happens, that creates noise, and that can be conducted noise.
Sure.
So what happens is your big long power wire becomes an antenna.
Okay.
And if you'll notice in this amplifier, there's actually a large cap here and a choke. Those are things that are used to keep the noise from the power supply chugging to come back out that connector.
So coming out of the amplifier, power and ground, it is quiet because of those components.
because of the filter that's in the way.
Okay.
Yep.
So that adds money.
Yeah, adds money, adds a little bit of size, but it keeps you from, once again, maybe not having your FM work, right? AM not work.
Yep.
Weird oddities happening, right? Like everything has two standards. One, how much noise you can make, and two, how much noise you can accept.
Ah.
Right? And so both those tests are ran
Okay.
in the accredited labs. For amplifiers, normally we're so immune to stuff because we're high power compared to like a low power like cell phone.
Oh, okay, sure.
We're pretty much immune to, you'd have to blast us with an EMP for to have a problem, right? Yeah. But we do have to test for both sides.
Okay.
So that's kind of one of that process. So as we go through this, right, you get an EV1, which is pretty typical, and that will be something like this board here, or mocked up and a bunch of jumper wires running around, something like this board there. EV2, you will fix problems that you found during. There's 4 things that we test for in the beginning. Initial checks is first. Initial checks looks for things like turn on timing, turn off timing, pops, muting,
Oh, yeah.
spiking on both power supply, Class D, and any data lines, right?
What does spiking do?
So the reason we look for spiking, so every piece of silicone, every power FET, every Class D FET has a voltage rating. 0 to 60, 0 to 100, 0 to 150, whatever it is, right? Well, you want to run, to get the most power out of that FET, you want to run it as close to its rated as you can, right?
Sure.
The problem with that is when you put something, when it's just sitting there idling, it looks great. Nice square waves, everything's under. But when you start pulling like 1%, 10%, 20% power out of the thing, which our customers do,
Yes.
that spiking goes up dramatically because the power supply is surging and pumping. And if that spiking gets high enough to where it exceeds what's called VDS of the MOSFET, you can get into something called avalanche breakdown. And what that basically means is that the spiking has gotten high enough over the rating of the FET that it's shorting the little silicone in the FET.
Oh.
And it happens, like if you're switching at 96 kilohertz, right? It's happened 96,000 times a second, right?
A second,
So
yeah.
it just depends on how fast you're running. But it sit there and tick, 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 tick. You have short. If you're actually in avalanche breakdown, because you can go over VDS on some FETs. It's silicone dependent and not get into avalanche breakdown. But if you go too far, no matter what, you will hit the thing called avalanche breakdown. When you do that, it's not a matter of if, it's almost like you just put a life number on the FET and said, okay, this amp's going to fail after this much time, depending on how hard it's used, right?
Yeah.
And that's very typical on a lot of products. You will see they will be into that spiking. It's one of the reasons we have such a slow failure rate is we make sure these type of things don't happen, right?
So when we're testing competitor products, this is one of the things you're looking at to see how they're handling this particular scenario.
To see how well they're built, to see how well they deal with the extremes of our environment,
our testing.
right?
Yeah.
So that's one of the things that we pay a lot of attention to. We do the same thing for the Class D output, right? Because if you're running it at 1%, it might be perfectly under. But if you're running at 10 or 20,
10 or 20% distortion. Yeah. Okay.
Yeah. And that happens on subs every day,
Yeah,
right?
yes, all day.
On mids, most people can hear 5 to 10% THD, and kind of it gets harsh for people to turn it down, right? But on subs, especially if they're in the trunk of a car, they might be at 30 or 40. They might be completely square waved over, and nobody even really noticed till they open the trunk and like, that sounds funny, right?
To your point, there are some of our customers, some of our friends that have never heard undistorted subwoofers. So when they hear a truly clean, high-quality system, they don't think it's loud enough because it's not distorted.
Yeah.
And it's so crazy.
No clipping. That extra tone has to be there.
Right, Kyle? Clippo, Rutherford. Hey, let's take a question real quick. I see we got a bunch of questions. Ernie, what's our first question for tonight? Frank. Hello, Frank. Any word on a big boy warhorse coming out, 10K maybe?
Well, we can't really talk about the future. That just doesn't happen. Definitely maybe, possibly not. I don't know. Right?
Thanks for asking, Frank. Brian, hey Brian, good evening. Hi Joe, thanks for your helpful information on my warhorse. What did you help him with?
We were talking about some things about he wanted to flip the whole board inside of it, which is not as simple as it sounds.
So the answer is no.
The answer is you can take it to a machine shop and then make sure you get good thermal paste back on it and tap and dye a bunch of holes. But yeah, it's not an easy thing to do.
Thanks, Brian. Looking forward to seeing that. Hey, Andy, good evening. Good to see you, sir. Does that come in a medium? You talking about this? Or this, medium? I don't know. You have to ask Ernie. He's the keeper of shirts. Watch your mail. Clint, does component placement with an amp matter? Good question.
Yes. Actually, almost more than the components in a lot of cases. So not only component placement, but trace size, trace width, and whether the trace jumps from PCB layers, right? So when you're looking at this PCB, you see one side, you see two sides. But in this case, there's 2 more layers inside of here.
Oh, wow.
In some of these cases, there's 3 to 6 more layers inside of there. All right, so you can actually have like a 20-layer PCB board. Now we don't. That's extreme. That's like an iPhone, right? Some of them will have 20-layer PCB. We do a lot of 4-layer boards, and that's kind of the most popular thing in car audio. It lets you, well, you just say an example. If you look at this, Steven, you might be able to zoom in here on this. You'll see. If you can get that close. So you'll see here, here's a 48-pin chip. Here's another 48-pin chip. There's a 32-pin chip. On some other amps, we have 128-pin chips. Each one of those pins has a trace that has to be routed somewhere to it. And then every little SMT component here has a trace that has to be routed somewhere else. So as you can see, after a little bit, you can't run everything on one layer. There's just no way. You can't even run everything on the top and bottom layer, and that's where the middle layers start to show up, right? So you can have 2 middle layers, you can have 4 middle layers. That's pretty common. You get above that, that becomes more like computers, cell phones, and that type of thing. And all those layers are used for either power or ground, because if you had power just laying here on this top, you'd have all these breaks in it, right? There's nowhere for it to actually go. So you normally have an inner power layer, a ground layer on the top or bottom, and then all the signals run in between and then pop out to stuff. Well, when you do that, you can get through every via or every corner of a trace what's called ringing.
So when a trace makes a right angle turn.
Yeah, which you'll notice most of ours are rounded on purpose, right? You'll see there's not a whole lot of sharp angles. It's all rounds and swoops.
Okay.
And even there, you still ring, right? So anytime you turn at all, ringing happens. So if you took a sniffer probe that could see in that frequency spectrum and ran it around the board, you would see wherever there's a corner, there'll be more noise there than there would be on any of the straightaways, right? And with that noise, those are the things that affect like SNR.
Signal to noise.
Signal to noise. Like how clean is your amplifier? THD floor.
Yeah.
Right? Data transfer, which is the big one on amplifiers that have DSP and micros in them.
Sure.
You have to make sure that that's, because all that's done in a PWM, right? So it's square, 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 square. At the other end of that trace, that square might be round or might have some spikes in it, right?
That's bad.
And so you have to filter it, and you have to make sure that your traces are correct, right? So part placement is very important, but also how parts interact with each other is almost even more important than that. Like, you got to keep certain data stuff close together, and then other stuff you can move farther away. Analog audio, you can move farther away, but then you have to make sure that you get it away from any noise sources, because you don't want to get noise source rating into it. So that is really the secret sauce. If you're like thinking of this as a soup, like the parts are important, right? You want good meat, you want good vegetables, you want a good broth. But really, when you mix it all together and spice it, that's what is the important part of it, right? Because you can make a really good amplifier with these parts, or you can make a pretty bad amplifier with these parts, right? And so it really comes down to the person doing the layouts. And we've been blessed with a few people here in this company, Fernando, definitely one of them, that can do amazing work with layouts. They really do. Sometimes I'm just stumped by like how he gets some stuff done and gets it through, and it's amazing the results.
That's great.
So that's some of the layout part. That's very important.
Other questions? Basshead, good evening. Joe is next level for Unmasked show. You're the next level. Absolutely. We love Joe.
I'm not getting to blow anything up tonight, so I feel like I'm disappointing you guys, but we'll try again some other time.
Is FP Fernando?
Yes, it is. Yes, it is. Good putting together.
Are you on here tonight, Fernando? If you are, say hello. A 3-meter lab. Oh, yeah. Go through that real quick, the 3-meter again.
So 3-meter lab, little around 10 feet, right? It's a completely metal shielded room, 1-inch thick MDF with metal plates on both sides, all bolted together with metal, grounded to the ground. A big 2,000-pound door that has copper teeth all the way around it, so when you close it up, it completely magnetically shields inside. And then you have ferrite magnets lining the inside to stop reflections, so you can get a real reading. And so the room is basically completely isolated. There's two types of what I would call anechoic chamber, like isolated rooms, right? This is like the EMI isolated room. The other one is like an anechoic chamber where you walk in on a net and you'll have film that's 6 foot to 9 foot deep all the way around you on 360 sides, and you can hear your own blood beating in your ear, right?
Weird.
There are a couple rooms I've been into that are both.
Yeah.
And those rooms feel wrong.
Wow.
Because the EMI, like even in this room, the EMI, when it's no longer beating on you just from cell towers and TV and radio, you feel like it's weird.
Really?
So if you go in there and close about a minute and a half, you'll start going, this is really weird. But if you do one that has both, it's almost lose your balance. Like you feel weird, like you feel off balance, you feel something's wrong, you want to get out.
Sensory deprivation.
Yeah, the sensory deprivation is really bad.
That's awesome.
So we don't have a full acoustic room like that. We have a partial that we do destruct testing here with. But we do have an EMI room now that's almost ready to go. So I'm pretty excited about that.
We got another question from Instagram. Will Kicker release 24 volt amps? What do you think about that, Joe? I know that comes up every couple of years.
Comes up every once. The only advantage you really get is a little bit of efficiency if you're not boosting a power supply, right? I know some of our competitors have taken 12 volt amps and just basically pulled their inductor out and pulled windings out of it and made it. You could do that, right? You could do a very dumbed down 24 amplifier. You basically just pull windings off it and make it work at the higher voltage, right? We haven't had that many requests for it. So I would say that's really going to depend on whether that grows and becomes a request that's enough to like make its own line.
What's a common application for 24 volt?
A lot of boats have tool batteries, so you can grab them there, but quite often it's golf carts and stuff like that.
Oh, okay, okay. So very limited market.
The golf cart market, the boat market's getting bigger.
Sure,
right?
sure.
So that one really depends.
Good question. Next question. Hey, Jacob, you're supposed to be taking a night off, man. Did Joe get a haircut? Oh, yeah.
I did. The wife has determined it is time for me to accept going bald.
Corbin, I noticed it today. These guys both work here. So
Oh, yes.
they had to chime in online.
Appreciate
Next,
it, guys.
real question. What do we got? Jason, this is why you always use authentic FETs and not generic or clones. What's he talking about?
So power FETs, Class D FETs, like there's name brands like Infineon, AOT, the list goes on. There's hundreds of silicone manufacturers, right?
Okay.
When you get into some of the cheap Chinese knockoff amplifiers, or some of those ones like that, to keep the cost down, you'll see like knockoff FETs.
Okay.
Right? During COVID, Infineon is the only company that has a patent and makes Class D controllers. So every Class D amp on the world, unless it's self-oscillating, so that's a different story, has a Class D controller in it, right?
Okay.
2042, 24, there's a bunch of different ones, but they make them all. During COVID, you couldn't get them.
Okay.
They went from 80 cents to $1 to $40, and that's if you could find them.
Yeah.
And we did a bunch of buying of those. During that time, a company knocked them off and made their own. Works fairly well. The protection's not so great though. So unfortunately, it has a tendency to cause amplifiers to blow up. But it's cheaper. So there's a lot of those more cost-effective amps that use like those knockoff FETs, knockoff Class D controllers, knockoff DSPs. Like so, other companies have cloned a part, right? 20-30% cheaper, and if you add that up over time,
sure.
Some of them work okay. Some of them have some issues. Just kind of depends on what it is. But you can't guarantee. So with the big companies like Infineon, if we say, hey, we're using this FET and we're going to put it in this new product, there's a thing on their website saying, hey, this is good for new designs. When the time comes up where they're going to EOL it, we get like a
end of life.
Yeah, end of life. We get like a 3-year window.
Oh, wow,
right?
Okay.
With those other companies, it'll just disappear.
It's just gone.
They just might be gone, right?
So you designed your whole product around that piece that's not available.
Yeah, and it might just disappear on you. So that's just something at our size that we just won't do, right?
Yeah.
We need to make sure for our dealer base that we have a good, reliable supply of product as much as possible.
Yes.
And the last 8 years have made that interesting sometimes.
Speaking
but we
of
do
which,
our best.
Can you give a short version of a long story of how we kept CX amplifiers in production throughout the whole pandemic? This is a great story.
So we had a meeting right at the beginning of COVID, after about 3 weeks in, when car audio went from Like the first 2 weeks of COVID, car audio crashed. Everything crashed,
Yes,
right?
everything, yes.
And then all of a sudden, car audio turned and went straight up at, like it was taking off as a fighter jet.
Yes.
And we made a cognitive decision at that point because we were getting ready to launch LX, we were getting ready to launch PXA, we were getting ready to launch a couple other products.
Yeah.
That all those were going to get held. And all the parts that we bought from those that could be compatible with the others moved over. So that bought us some time. Then, what I talked about a little bit before, buying Class D controllers. We had to buy other stuff too, but Class D controllers were the biggest. And it was to the point where we were paying $30
Wow.
a chip for a Class D controller. Well, if you were a dealer during that time, you'll notice that we didn't really raise prices on the CXA 401,
Right.
801,
Right.
which are the two biggest selling amps in the US, right? They're number one and number two. And with that, we were basically losing money selling the 400 watt amp, right?
Yeah.
But it was to keep everybody moving product and keep everybody in business, because
Yes.
if they didn't have amplifiers, they can't sell speakers. What are they going to do?
Yep.
So myself and Colin, the PM for the electronics, would sit on the web during the day searching, and at night talking to vendors all over the world, trying to find anybody that had batches of real 2042s, 2041s, and buying them up.
Yes,
Right? And
yes.
then shipping them wherever we needed to ship
Yeah,
them.
whatever we could pay for them.
It got pretty steep. I think 38, 33 was like the highest we paid for an 86-cent chip. Yeah.
Wow. Painful.
It was painful, but it kept product moving, and kept a lot of the dealers happy. And I mean, everybody else wanted all the other amplifiers, right? You always want what you can't have.
Yes.
But no, I mean, the complaining was there, but it's pretty low because they all had product, right?
Yes,
Whereas they
yes.
saw kind of a nothing from most companies, right?
Yes,
You just
yes.
stopped. That was I never thought I'd live through something like that. It was a crazy time making product.
You
It really
guys
was.
kept the doors open, quite literally.
It was
thank
different.
You.
It was very different.
Question, Kicker. A lot of trucks in Australia are 20 volts, and it would make it much easier to fit audio without relying on DC converters, and also hard to find out the correct amperage. 24 volt amps would make it much easier. Australia. 24.
Interesting. What brand? Can he answer a question? What brand of trucks?
Yeah. What?
He's on Instagram, so I'll just have to wait for him to reply.
Okay, that's
Okay.
fine.
Thanks, Colin.
That's interesting. That's not something I've seen except in like hybrids or electrics. So
We'll have to ask Chet about that. Maybe they are hybrids.
They
That
might
could
be hybrids, yeah.
Huh. Good question. Thank you. We'll have to get back to you on that. So what's next question? What do we got? Got a lot. Danny. Good evening, Danny. Joe, how are those true wireless amplifiers coming along? When can we expect true wireless?
true wireless.
What? We've got earbuds that are true wireless.
There are multiple ways to send audio wirelessly through a car that would work just fine. The problem is, no matter what, we still got to wire power ground, right?
Right.
So except for the cars where the battery's in the rear, Corvettes, some Chryslers, BMWs, you still have to pull the panels to run the wire. I don't know if people would pay
Yeah.
to have that done. It's not impossible to do. You could do it with a couple modules from Amazon right now if you really wanted to. But not something we're currently working on. How about that?
Not in a hurry to do that. Other questions? Hello, Mr. EE. Do the people who make the transistors keep you up to date about new MOSFETs coming out so it helps keep you ahead of the curve, or do you only see what they have released to the public? Good question.
Depends on the company. We have some very close relationships with some of the vendors. ST, TI, Infineon, Microchip, Analog Devices, AKM. So a lot of the DSP, FET, and micro people, we have very close relationships here. They're here once a quarter at least.
Yeah, I see them running around.
And so we do see new product ahead of time. In fact, some of the stuff some of those companies make nowadays in their main lines are because we've asked for it. So it allows us to see new stuff. GaN solutions, like we haven't made a GaN amplifier yet just because of cost versus performance and where we'd sell it and where that fit a product.
Sure.
But we've been looking at GaN since pre-COVID at this point.
Wow.
So and playing with
Cool.
it.
Good question. Before we take another question, are we on track, Joe? Did we skip over anything that you wanted to?
We haven't talked about getting close to production and getting past production, which we can do.
Let's do that a little bit now.
Okay, so I kind of stopped where we were at the point where we knew what we were going to build and we were starting to make EVs, right? So engineering validation models, it can be as many cycles as it needs to be. Hopefully on most product it's one or two, right? So EV1, EV2 shows up. By the time you get to that point, we've kicked tooling off. Tooling is time consuming. It can take 30 to 90 days.
And what exactly is tooling?
That is when you make the actual housing that the product goes in, right? So this aluminum housing has to get tooled, this plastic end panel has to get tooled, this plastic end panel has to get tooled. You've got to tool the screws quite often because we don't use off-the-shelf screws. Bottom plate has to get tooled, and any mounts for the FETs or for any of the stuff inside, you have to tool all that as well.
And tooling is not cheap, right?
It's never cheap, but it's like, there's two types of tooling. So this is called an extrusion. And how this works is they take semi-warm aluminum and push it through like 20,000 tons of pressure into a form, which causes the aluminum to take the shape that it's getting pushed into.
Like my daughter's Play-Doh hair set.
Yeah, basically.
Dial it up and cut.
So this amplifier will get pushed through and there'll be 40 feet of this housing. And then the housing gets cut to the length that we need, right? That tooling for that piece of metal is like probably $9,000.
$9,000.
Yeah.
Okay.
That's the cheap one. Yeah. In panels are going to be another $3,000 to $4,000, depending on how complicated they are. Inside stuff and a stencil for the PCBs. It's part of the development path and stuff. That stuff all adds up to another couple $1,000, $3,000. The other type is what we did with the LX housings or the PXA. There's a good one.
Yeah.
So this is called a casting. So with a casting, you can make much more complicated shapes because you're not pushing this through a piece of equipment. You're taking liquid metal, you're pressurizing it into a mold, and so that mold can be almost anything as long as there's a bit of an angle draft to it to release.
Okay.
And that's how you get these side fins and the unique shape and all that stuff that you see in LX, PXA, product like that. Those ones, for example, the casting for the big amp alone is $35,000.
$35,000.
The whole line was like almost $100,000.
$100,000 just for the tooling.
Just for the tooling for the looks, right?
Yeah.
And then you have all the other stuff. We had to tool a rubber plug. We had to tool all the connectors, the cables. All this stuff is custom, right? So every last part, the bottom plate, the cover for the controls.
Yeah.
All that gets tooled, right? That's kind of the advantage and why you see a lot of the small companies buying stuff that was called off the shelf, right? They can change the housing a little bit, they can change the color, but you open the amplifier up and it looks very similar to something else. It's a lot cheaper to do it that way than it is to try to make something from scratch.
So a bunch of small companies are getting cheaper because they're using all the same tool.
Yeah, they're sharing, right?
They're sharing. Yeah.
Then they call that open tooling. It happens in headphones, earbuds, mini speakers, car audio, subs. It's everywhere, right? Anything you can think of, there's what's called open tooling available for something.
Yeah.
Right? Not to be exactly what you want, but it might be close enough to work, right? Save you a lot of money. So when we get done with the tooling, that will be what we call DV1, design validation. That's when we can make sure the amplifier sits in the housing right, the connector fits through the holes right, everything lines up, all the FETs mount correctly on the housing. Like there's nothing that needs to be changed. Normally, that takes 2 rounds. First off-tool sample is never right. It's close, but never perfect, right? There's just too much to it. And so DV2 is normally where you kind of get that figured out. God forbid, you might have to do DV3, but we try not to.
Yeah.
When DV3 is done, electronics are done already. Software's probably done already. Like you're just figuring out the mechanicals. And so then we'll do what's called a PV run. And that's really a production validation run. Go to the factory, we set up the production line start to finish, and that starts out with a blank PCB, right? This will come in from a third party with nothing on it. All the surface mount parts, all these little things will get put on the board by automatic machines, go through heating, get soldered on, and then at the end there'll be an automatic AOI machine that will literally look at every solder joint.
Oh, wow.
And make sure they're all good. Two-sided, whatever we have. It moves from there to the production line where then through-hole parts go through, the caps, the big power stuff. That goes through a wave solder. Wave solder has to be set up for each product a little bit differently.
Wow.
Depending on how close the caps are together, what's in the way of what else. And so you can change both the frequency of the wave, it'll sit here and vibrate, and you can change the width of the wave and how many waves there are, and the temperature of the wave, which goes up and down. And you get it just right, it'll completely cover the bottom of the board, almost 100% perfect. Comes off, flip it over, you add some extra solder to some joints just to make sure because they're high current.
Sure.
And then it goes down the production line, right? And so each stage of the production line, we have an SOP that we've created.
Standard operating procedure.
So there'll be pictures of good and bad and what's pass and what's fail. In general, on all of our products, pretty much every amplifier we make, it will go through AP testing at least once, sometimes twice, which is the same testing we kind of do in the lab for signal noise, power, frequency response, THD,
Yeah.
crossovers, make sure they all work
So there's
correctly.
APs on the testing
On the production line, right?
Yeah. Yeah.
We'll go through a burn-in, and when we do burn-ins, they get fixed to the lowest impedance load, full power, and go through 3 heat cycles, if they'll heat cycle. Amplifiers like the Key won't. We have thermal rollback, same thing with the LX.
Yeah.
So then we have a preset period of time, so it gets up into thermal rollback and goes all the way down to the lowest level. Once it's done that, then we'll call it good. It comes out of there and goes through final packaging, final cleaning, final tests again after burn-in to make sure it's still working.
Of course.
And then into packaging, right?
Wow.
And so it has to be done for every model of every amplifier, and they all have to pass our tests. That costs, and some of our processes cost us money, right?
Yes,
Because
yes.
you're paying for labor, you're paying for equipment
Yeah.
on the line. A lot of amplifiers that are built for car audio never go through AP testing. They literally are built, will hit burn-in of some type, go to a scope where they make a sine wave and make sure the sine wave gets up to 20 volts or whatever, call it good and just package it, right? Well, that's a lot faster process. But for us, we want to make sure that when you get a product, the 98.9% of the time, you get a perfect product, right?
Yeah. Yeah.
Because that's what we're trying to tell you we'll do for you, right? And
That's
that's our
value.
goal.
Yeah.
That's the value we're trying to add. When you put it in as an installer or when you buy it as a customer, it's right. And that's our goal, right? And you don't always get there, but that's what we strive for, in
Right.
everything that we do.
Well, real quick, the failure rate on CX amplifiers is shockingly low. Please tell the audience what that is.
Currently on the latest model line, which is the 46 KXAs or CXAs,
6A, yeah.
at this point we're averaging like 1.1% actual failure when they come back.
So out of 100 amplifiers, one of them fails.
Yeah, if that. In most cases on the monos, it's like 0.87.
0.8, less than one fails.
And that's not bad out of the box. That somehow blew up in the field, right? Whether it had bad ground, poor ground, speaker shorted,
Yeah.
whatever, right?
Customer abuse.
Yeah, the protections worked and did what they were supposed to keep an amplifier alive, to keep working, right? That's our goal. We've
That's
been able to
phenomenal.
do that by making the CXA line incremental improvements over
Yeah.
the last 12 years, right?
Yes.
It's not the same line, but it's a very similar line. And so each time it changed or grew, we fixed this, or we made this better, we made
Yeah,
this more robust.
yeah.
And so by the time we got to the point we are now, all the stuff that we would see, because this is one thing that's unique about us, we do our own amplifier repair in the back. But what we do before that is the first 20, 50, 10, whatever it is to put on the product, they come back to my group, we pull them apart, take a look at them, see if it's a production problem, see if it's a design issue, see if we see something that pops up more than once, right? And you start seeing that, then you make it running change and we fix it.
So real quick, so what you're saying is when a new line is introduced, like an LX amplifier is introduced, when the first several hundred go out, if any of them come back, they go straight to you.
It's more like when the first 5,000 or 6,000 go out, when the first 10 or 20 come back,
Okay, so
they come to us.
they come to you guys, and then you go through
We
them.
go through them all until we get to a point where we feel comfortable. We haven't seen a repetitive failure. Like
Okay.
this is something we need to fix. Then we'll allow them to go back there and just be repaired and refurbished and sent back. Until then, they come to us. At this point, we've only seen like 2. So it's going to be a while before we get to, because we need to do that for each model,
Yeah.
right? We've only seen 2 7-channels at this point. And neither of them are actually bad. But so those don't count. Because if they're not actually bad, they don't
Yeah.
show us anything, right? So
Yeah.
we've got to keep going until we get enough back to where we see some failures and go, okay, this is what we can do to fix this or make this better. Same thing with the Warhorse. We've had very, very, very few failures with the Warhorse, but we have one guy, Drew, if you're watching.
He was just here.
I know he was. Yeah. That his amplifiers are mounted in front of his subwoofer box in the cabin in the pressure zone, right?
Yeah, yeah.
And he's vibrating the amplifiers on the rack so much that we're having some components actually pull loose the PCB.
Oh, wow.
And so we have a Drew mod that has
Drew's got his own
been applied to these amplifiers in a running change to make sure that can't happen, right? Because the transformers in the Warhorse are like twice this size. They're heavy.
Yeah.
They're already glued down to the PCB and soldered through the PCB. That doesn't seem to be enough for Drew.
Yeah.
So now they're strapped to the PCB So you literally have to rip the PCB in half to take them off, right?
Drew, I hope you're watching tonight.
He knows this already. We've talked about it, right? We have the Drew mod.
That's great. Let's take a couple more questions.
Coming to a Warhorse near you.
So what do we got? And if Drew's here, give us his question. European trucks like Scania, MAN, and Volvos are 24 volt.
Interesting. I'll have to dig into that some. I haven't seen those.
Thank you.
Are they hybrids or not hybrids? Or are they just normal trucks? They could be normal trucks. You can start a truck off 24 volt and stuff. We looked at it in the States to do 36 for a long time, and they killed it because of the fuse costs, because the fuses will pop easy. But
So that may be something to look at. Brian, good evening. When you get to the end life of a product, do you destroy the tooling to prevent counterfeit?
we actually bring it back to our own. We have employees in Asia. We also have warehouses. In most cases, unless it's somebody that's like a partner that we've been a partner with for 30 years, we actually bring it back to us and destroy, yes, on purpose. We still have, I don't know if any of you have gone to like the Philippines and gone to a car audio store. There's still some pretty good looking knockoffs out there. Like they'll literally have a line of, this is official Kicker product with the real price, and they'll have, this is knockoff on this line right next to it. And you start looking at them, and some of them look pretty good until you like push the woofer and you realize it's like flops around, or you flip the amplifier over and open it up and there's like half of nothing in it, right? But the actual outside look, it's pretty hard to tell if you don't really, looking real close. Packaging looks close, right? Like,
Don't know what you're looking at.
But those people have tooled their own stuff and are trying to make money off of our marketing and brand, right?
That's painful.
It is.
Next question, please. Mel, good evening. Is the most common failure user error?
The two most common failures we see are reverse polarity, i.e. you plugged in power and ground wrong and the fuse was so big that it blew up the amplifier instead of blowing up the fuse first. The second biggest failure we see is blown output FETs. And yes, that's a user error. The output FETs on one of our amplifiers, because we use them within their operating parameters and we have very fast acting protections, 95% of the time that's user abuse, one way or the other, right? We don't treat it as that because we believe everybody's like a family extended, like that's how Steve's kind of thing is.
Yep.
And so we warranty everything. I mean, if you look through Facebook, you'll find us like sending people new ZX amps last year that the guy had a hurricane and knocked his house down and got wet, and so we had one laying in the back somewhere and we sent him that in a woofer, right? Like we go to the extreme to try to take care of our customers, and so we don't look at it that way, and we look at it more as like, okay, they blew it up. All right, how'd they blow it up? Because we do everything possible that they can't blow it up, right? So then we dig more into it to try to make it even more robust. And like I said, we're down to about 1%. And to give you an idea, like the 43 series of CXAs, the ones that were 2 ohm stable, they were around 2 to 3% failure rate, which is still unheard of. Most car audio stuff's anywhere from 7 and up.
Yeah.
Because it's just our kind of marketplace, right?
Yes.
We use stuff the way we use stuff.
We beat on it.
And so just the continuing improvements, we've gotten down to a point where now it's almost like, right, like there isn't much else we can do to them to make them that more robust at
The
this point,
Maytag
right?
man.
Yeah, he doesn't have anything to do, right? Yeah,
So one story I want you to tell, several years ago, we went through an amplifier phase where we were building regulated amplifiers. And they were fantastic performers, but there were some customer challenges. Give us a brief history of that. And what is a regulated versus
so regulated versus unregulated, right? So there's multiple power supply schemes, whether it's boost, split rail, like old Soundstream stuff. There's a bunch of ways to do it, right? But in general, there's two things you can do with your power supply. You can either take 12 or 14 volts in, and you can make your 30 or 60, 90 volts, and you can try to hold that voltage, or you can have that voltage swing with the input voltage, right? That's either regulated or unregulated. You can also do like a regulated that's kind of semi-regulated, right? But in all, if you're going to try to hold voltage, what has to happen in physics? You have to pull more current.
Yes.
So in the lab where we have 300 amp stacks and huge power wires, you can take a 2400 watt regulated amp, pull 300 amps through it all day long, and it's great. Works like a champ. Go down to 12 volts. It barrages like 400 amps. It still makes 2400 watts, right? At some point, the power supply stacks, but we have a couple 1,000-watt power supplies back there, right? So we can, it'll make power all the way down to 11.5 where it shuts off, right? Problem is, this current goes dramatically up.
Yeah.
Well, you put that in a vehicle. The amp has single gauge input, hot gauge, right? You got a 17-foot run. You got a 240 amp alternator, a big yellow top battery, whatever you have. Lithium wasn't big back then. And you start playing bass notes on it, and you'll notice the peaks are 450 to 500 amps. Well,
Wow.
aught gauge at 12 to 17 feet is only really good for about 300 amps of current, 250. Anything more than that, and your voltage drops like 20%, right? So even if you're 14.4 at the front, you're now 12, 11.5 at the back.
Yeah, yeah.
And we just try to pull more and more current, right?
Yes.
But that's the problem with a regulated amp in a car. If you had a perfect world where people ran 3 aught gauges, put them in a distribution block, and ran over to the amp, okay, great, right? Aught gauge is expensive. I don't know, you looked at that lately, but
Yes.
it could cost as much as your amplifier you're buying.
Yes.
And so we had a bunch of problems where somebody would buy like our 800 watt amp and somebody else's 800 watt amp. Ours would go in the install and it would shut off all the time when they turn the bass up. They'd throw an unregulated amp in and it would just work, right? Because
Yeah.
they just make less power.
Yes,
So it's
yes.
making like 480 watts, but 480, the difference between 480 watts and 700 watts is almost unhearable.
That's
it's real,
right.
It's real close, right?
Absolutely.
So they wouldn't ever know. So we made a conscious decision at the end of the KX line that everything going forward was going to be unregulated. Mainly because it just makes it more user-friendly. You
Yes.
can put it in. Yes, we still want you to have a good ground. Yes, we still want you to have good power. We want you to be able to supply as much current as you can. But if you don't, we're still going to work for you, right?
Yes, yes.
And so the LXs are unregulated. One of the advantages of the LXs being unregulated is how much dynamic power they make.
Oh, yeah.
There's also another circuit in there that we've come up with that helps do that. But these amplifiers are very, very dynamic. And what that means is, so like with a steady state sine wave, how we test an amp in a lab, it makes 1,000 watts, right? But in these amplifiers, if you hit it with a pulse, like a bass drum or a beat, it'll make 1,500 watts.
Wow.
1,600 watts, right?
Unclipped.
Unclipped.
Unclipped, yeah.
Because of the way this is designed. And so that gives you very nice headroom
Yeah.
with music to where you don't get into where things start to sound a little harsh
Brittle,
when they start
yeah.
to clip a little, right?
Yeah, yeah.
Especially on the full range channels. Like these things are already making a ton of power, 140 watts or so on each channel almost
Yeah.
on most of these. Well, that's a steady state, so dynamically they're making a lot more.
Yes.
And so you have all this headroom, so you don't have to get into the THD with the gain.
Yeah.
You don't have to worry about like, getting harsh at high volumes, as they just don't. So those are advantages of going the way that we did, and that was a conscious decision with Warhorse, LX, PXA, and everything coming forward at this point, to be honest.
So let's take a couple more questions because we are, man, it's 25 after 8. I can't believe how long we've talked. It felt like nothing. So
It's nothing. We haven't got to that amp yet.
I know. Let's take a couple more questions. Choke change, good evening. Modern full bridge amps versus modern half bridge amps.
Pros and cons. One costs a little more to make than other electronically. The other one's normally a little smaller, so you have less material on the housing and that stuff. So depending on the design, one might cost less than the other. Pros and cons. The power supply is different for them. One's not more reliable than the other. It depends on how they're built. Because the reality is, if you take 2 half-bridge amps and do what's called strapping, right?
Strapping,
what did you
yeah.
just do? You made a full-bridge amplifier. Because that is all a full-bridge amplifier is 2 half-bridge outputs, and you're driving basically, most of the time, the negative, we won't get into that right now. You're driving one of the outputs full swing, and the other output references ground. That's a half-bridge.
Okay.
On a full-bridge amplifier, one side drives full swing this way, one side drives full swing the other way, right? And they're out of phase with each other, so you get twice the sweep. That is it. So if you take 2 half bridges and you use that little cable that goes between them, what's that cable do? It flips polarity.
That's it.
It's a 3.5 millimeter that flips polarity from one side to the other. And you plug it in, and it feeds the signal from the first amp to the second amp. So guess what? Now the second amp's out of phase. So when you plug those into your speaker leads, one pushes and one pulls, just like a full bridge. Advantages, half-bridge amplifiers versus full bridges. Half bridges can be bridged, so if you have a 2-channel amplifier and you have 2 half bridges, of course you can bridge them.
Yeah.
A full bridge amplifier is already bridged; it can't be bridged again.
So for an example, a KXMA 1202 is a full bridge amplifier.
It's already bridged, yeah.
So it's our marine amplifier. It does 300 by 2 at 4 ohms, and it's really designed to drive our KMTC 9 and 11 inch cans. But you can't bridge it to make a 1200 watt mono channel.
It's already bridged
It's
internally.
already bridged, yeah.
The Key 204, full bridge.
Full bridge.
right? This drives both channels. These half bridge, right? So it really just depends on the design and the intent. People have a tendency to say, because a lot of the full bridge amplifiers that are out there in the SPL space are very cost effectively made, that they're not, that full bridge isn't reliable. That's actually not the case. It's that amplifier design is not reliable, right? We've been making full bridge amplifiers since the late 90s. So they've been around forever. It's not just us, JL, Fosgate, take your choice, right? They've been out there forever. They're very reliable. They're just different. Right?
Designed and built.
Yeah. It takes 2 Class D controllers, takes some extra stuff, right? But because you're driving both sides, you can shrink some other stuff, and so you kind of get
trade-off.
Yeah, trade-off. Everything's a trade-off in physics, and which is what audio is, especially on the electronic side. So there's no definitive answer. It really comes down to who did the design and how well the design is made. That's really what matters, right? Full bridge can be a little smaller physically, which is nice if you're trying to fit it in a hole somewhere. Half bridge will be a little bit bigger, right? But you can do both.
This next question, same gentleman, can you feed the output from an LX with DSP and shockwave to the input of a Warhorse?
Yeah, but all our sub-channels are pretty big, so you're probably going to keep the gain at minimum and maybe even put a voltage divider in front of it. But yes, you could do that.
Okay. Try it, let us know how it goes.
You want to stay under 40 volts, right? If you go into high level in, we can only take 40 volts, so...
Only, listen to you.
Only. Well, yeah, 40 volts is a lot. But
it's 400 watts at 4 ohms.
But still, those sub-channels are bigger than that.
Yeah, they are.
So,
Wade, good evening, Wade. Do you have target signal to noise and total harmonic distortion ranges for the different lines of amplifiers, or is that a byproduct of the other deciding factors that go into them?
We always have an SNR THD power number at each impedance that is our goal. Normally we try to meet and exceed them. In most cases we do. In some cases we've had to adjust our goals because of the product and the price point or whatever it had to fit into.
Right.
But normally whatever's decided in the beginning, yes, we go out, that is what comes out of it in the end, or better, right?
I want to add on to what Wade is asking. CEA standards. Talk a little bit about CEA standards.
So traditionally everybody uses 2006C. 2006D came out, was it pre-COVID? It might be now. Sorry, I'm losing some years here. When I was on that team. 2006D is actually a very good test standard, the new one. 2006C was really easy to fake, right? There was no enforcement, there was no nothing, and the tests really weren't that hard on an amplifier. 2006D, you have to send it to a third-party lab to get it done. The tests are actually very similar to our tests. I was on that committee. And it's a good test for an amplifier, and it gives you enough flexibility in the numbers you can put on the packaging to be effective.
Okay.
Right? Old 2006C had 4 ohm power. That was it. 4 ohm power on a 4,000 watt sub amp is useless, right?
No one cares.
Yeah, no one cares. So the new standards are better. The way they're doing testing is very similar to how we do testing. I like the way that they came up with it in the end, and I like that they actually started making accredited test labs to actually test it. That's the first step to creating a real standard that maybe at some point could be marketed and people might understand what it is.
Yeah.
Because that's the biggest problem right now is like anybody that's not really in the industry has no idea what CTA 2060 is, right?
Yeah.
And at some point, that's the next step for CTA. They need to figure out how to create the consumer awareness of that standard,
like
and
Dolby
that value. Yeah, like
has
Dolby,
done, and DTS,
Bluetooth,
THX,
DTS, any of those stuff.
Yeah.
High res, whatever you want to call it, right? All that stuff, you need to market it.
Yeah.
And if they do that, I would be happy to look at putting it in our packaging. Right now, it's the same numbers as we already have, and so it doesn't make sense to take up more space to do it. But if it actually became enough to where they actually got out there and did it, I would be happy to because it's a good standard now.
If the consumers were asking for it,
if the consumers
then
can
it
get
would
to the
make
point,
sense.
it's a good standard now.
Yeah.
Yeah, they do. It's really well done.
Let's take 2 more questions. Next question. Mario, good evening. Can you use the LXC to tune the LX3001? And if so, I need help. It won't set the high pass where I want it. Keeps resetting to 10 hertz.
You cannot use the controllers for the 5-channel and the 4-channel to control the monos, no.
Say that again.
So the LXCC is the controller that comes with the 5-channel and the 4-channel LX amp.
And the 7-channel.
And the 7, sorry, yes, the multi-channel amplifiers.
Yep.
It was not communicate with a mono amplifier. You have to use the normal controls on the end panel for that.
Awesome. Good question. One more question. What do we got? Scott Williams, long question. See if I can do this with one breath. Joe, when looking at the inside of amplifiers, we see a lot of different colored boards. Is there a quality change based on board color? It seems like a lot of high-end amps have black or red. Mid-level amps are commonly blue or green. Something I've been wanting to ask for a while.
Okay. Green is the cheapest, period. Green PCBs, they're the most popular used, so they're a little bit cheaper. Once you get past that, all the rest of the colors except for purple, stupid expensive, don't do. Yellow, stupid expensive, don't do. And there's 2 other colors that are stupid expensive that don't give you anything, right? There are some actual physical advantages and disadvantages to some colors. Black, unfortunately, has a tendency to have the solder mask pull at the corners. So even though it's a really good looking color and looks good when you lay everything out on it, it can have a tendency to look dirty and then can have where the actual solder mask, which is the color, pull up in places when you start doing production runs. Like on one sample, it'll look real good, but you do 10,000 of them and all of a sudden you have these ones that have bubbles in the corners and this and that. Because this is an ink that's basically laid over the product, right?
Is the problem because of the color or the
it's the color? It's the chemicals in that particular
okay,
color,
that
right?
Make that color, okay.
So black can be problematic. Some we like using black because it looks good. It's one of our popular colors. We've also used red in all of our KX amps and that type of stuff. We looked at doing, this color is, of course, Kansas State for Ian. Right? That's his color. That's not his board design, but that's Kansas State purple. We've looked at a bunch of different colors, and there's like red, black, and like 3 or 4 others are all the same price, and then you have the other stuff that's like esoteric and gets more expensive, but it doesn't give you anything, right? But there's something we don't talk about. Like this could be made out of FR4, FR3, some other type of material, right? And so the thickness of the copper can be different for each PCB. You can have 2-ounce pour, you can have a 1-ounce pour, you can have a 4-ounce pour of the copper on each level, or on each, if you got a 4-layer board on each layer, you can have 4-ounce copper thickness, 1-ounce copper thickness. Those are more important than the color, to be honest. Normally the color is a choice of either looks or what was available from whatever board vendor you're using that they happen to support at a decent price versus looks okay, right?
Crazy question.
That's a good question.
Love it. So let's talk about the final amplifier that we have in front of us.
So the final amplifier we have here that we talked about a little bit, like the tooling of the extrusion and the end panels, right? So this is the key amplifier. For those of you guys that know this is a self-tuning DSP amplifier that when it first came out as the Key 184 was under $200.
Yeah.
It was a complete industry changer, right? Nothing had ever been done like that. So this was actually, we talked about this whole process where the product ideas come up and everything else. This was more of a R&D push, right? So we have some products that come out of R&D because we want to do something different. We think there'd be a spot for this, but there's too many unknowns in the path to even try to put it in a 3-year plan.
Yeah.
So what happens, we take an engineer, quite often it'll be one of the newer guys when they're learning, we'll give them a project to learn on, right? So the goal for this one was originally to be a self-tuning amplifier under $200 that would compete with the Alpine Power Pack that was real popular at that time that was not self-tuning, right? When we finally got all the software done for the self-tuning and all the hardware working, and we said we wanted it small, I have a certain engineer who was a little bit of an overachiever, and this was the size of the 50 watt by 4 amp. So to give you an idea, right?
Can you go to the close-up?
About half the size of
let's go
what the actual key is now, and the key is pretty small right now, right? So this amplifier is very, very small, still made 50 watts by 4, but we had a couple issues. One was, we took it upstairs, And all the sales and marketing people were like, nobody will believe it makes 50 watts by 4. You got to remember, this was 12 years ago.
Yeah,
almost,
yeah.
At this point, or something like that. 10 years ago, at least now. The second problem is it came in overpriced because the components that we used that allowed it to make it this small were just very, very expensive.
Very expensive, yeah.
So to fix that, right, we had to actually go the other way. We made the product bigger to be more about the same size as the competitive product and cost down,
Yeah.
right, to get it to fit that price point we were shooting for. And this has been a great product for us.
Hugely
I still think this
successful.
would have been really cool.
Yeah. It's not too late, Joe.
It's not really complicated, but really cool. Right? So that's the last little piece of Kicker history I had to share for you for like the development side.
Well, that's great. So are we still online? I'm looking at a Google screen. Okay, there we are. We're still broadcasting. All right, good. So we want to keep Joe here because we've got 2 tech questions that are perfect for Joe. So let's go straight into technical questions. And Joe, you're cool to hang out,
Yeah,
right? We
I'll
already
hang out.
cleared that with you. So the first question we have tonight is, I see you all claim to run the WXA 3001, that's the Warhorse, at 1 ohm. But I've seen guys in my audio groups talk about it being able to handle 0.5 ohm. Is that safe? Any extra power if I do that? Joe?
Depends on your setup, right? An amplifier technically doesn't know what impedance you're playing at. We have no way to know that. I mean, there's a way we could do that, but we don't, right? So we currently don't know what the impedance is that you're playing at. Only thing we know is how much current you're drawing. So the reality is you can wire it up to like 0.3 ohms, and as long as you didn't play it very loud, it would play just fine because we have no idea, right? What we do know is how much current you pull. The reason people can get away with wiring it to half ohm in their system is there's a thing called box rise. And depending on how your box is made, if it's ported, you'll have 2 very big peaks that will happen in the bass range, right? And what happens is the 2 peaks will be on both sides of the FS of your port. So if you're ported at 30 hertz, right, you'll have a peak of impedance rise at 20-ish, you have a peak over here at 40. Well, most music isn't one note.
All right.
So it'll be a blend of those notes, right? The average current is probably going to be higher than 1 ohm, and we're not going to know. Unless you're clipping it at 30%, and then we might know. If you have a single box, you get a bigger rise at the FS of the speaker, slightly adjusted by the size of the box, right?
Sealed box.
Sealed box,
Sealed,
yeah.
okay.
So with a sealed box, it'll move, you'll take the FS of the speaker, say it's 30 hertz, and depending on if it's a big sealed box or a small sealed box, that spike will move a little bit left or right, but it's usually a little bit wider than the peaks that you see with a ported enclosure. In most sealed boxes, because that peak is down low, unless you're playing sub 20 hertz and down, and running it really hard, yeah, you can probably get away with it. Do we suggest it? No. We've designed it to take 1 ohm, as much abuse as you possibly can do to it, and it will survive for years to come, right? At half ohm, it's still going to survive. It might shut off every once in a while, but you have to realize anytime you hit a protection on a product, whether it be low voltage, over current, over temp, those protections happen in milliseconds, right? But there's still a split second where you've exceeded whatever that material in those FETs or that product are capable of. So a little bit of damage happens every time.
Yeah.
I had a guy, not the same amplifier, but kind of to put this story together, had a guy call, went through all of our tech support all the way down to me finally one day, because he'd gone through like 3 605 CXs, blown up.
600.5s.
The 665s, the 5 channels.
5 channel, okay.
All of them blown up. Same way, all the FETs are blown up on the output.
Wow.
Right? Go through his system, come to find out he's using CCA 4-gauge wire.
Copper clad aluminum.
Yeah, and it's 17 foot all the way to the rear. He's got a ground path running down to a bolt, the seat bolt. It had like 2.5 ohms of ground resistance under load.
Wow.
Like when it was normal with a meter, it was fine, but when you loaded it, you could do the math and it was bad, right? So I sent him a power kit and 17 feet of ground wire and replaced them himself.
Yeah.
Its amp's still running as of last year, the last time I talked to him, right? And so what he was doing, he was right on the edge of hitting under voltage all the time. So his amp would almost shut off and come up, shut up. And because it never completely shut off, if you looked at the amp, you could see the light blink.
Yeah.
Because the protection light will blink a split before we actually pull audio, right? he was right along the edge, and so he was hitting their phantom protections, 100 times a day. He drove an hour and a half to work,
Wow.
hour and a half back each day.
Yeah.
And so he was just sitting there doing this to it all the time. Well, sooner or later, the FETs go out, right? You're damaging them the whole time. So if you use it within the way it's designed, it's going to last, lifetime, 20 years. We've got a bunch of old ZX amps running around still. Right?
Yes.
If you use it outside of its spec, that can't be guaranteed because every system is different. Do you have a big lithium bank? Are you able to hold 14.4 so we draw less current? Does your box rise enough, right? Like, it's hard.
Yeah.
We can't, that's why there's no generic answer that can say, yes, you can do this, or no, you can't, because everything is different in every car.
Right.
Unfortunately.
Good answer. Way better than what I would have said. I would have just said
No.
Okay, next tech question. I've set up the key amps in both mine and my wife's vehicle. They sound great, but I would like more power. Any way to boost the output?
Turn the gains all the way down and put an LX in front of them, or after them.
There's a video on how to do that on kicker.com.
There is. And don't grab a CX 300 for 364. It's not enough power to make a difference.
John loves that combination.
I know, but
Just
it's
saying.
not enough power to make much difference, right? This makes 54 watts, and that one makes 67 or 70, right? If you're going to put more power and you want more power, grab an LX 504 or a PXA 404 if you don't have a lot of space. That's a 5-channel, but the 4 channels look that big, right? And that makes 125 watts by 4. These ones make like 140 watts by 4. Put those after it, and you'll be fine, right? Just keep the gain down so you keep the THD floor down.
So you get all the DSP control of the key and all the power of the LX.
Yep.
Awesome. Okay, great questions. Now let's look at fail picks. Oh wait, no, we decided not to call it fail picks. I mean, what do we call it? Fail picks. So everybody loves fail picks.
Uh-ohs.
Exceeded manufacturer's recommended installation. So we're going to show you some fun pictures here. Now again, if this is your install, we're not trying to make fun of you. We're just trying to have fun. Well, I'm trying to have fun with you next to you. So Joe, you're going to love this. So what's going on in this install pic
That's like
here?
half the cars I saw back at my shop in the day when they come in. That is, I can't find a way through the firewall, so I'm going to run it through the door, the edge of the hood, and into the door, and around the door rubber, and down through the carpet.
Grommet? What's a grommet?
Yeah.
No. See,
There you go, yeah. Oh, he didn't even put it under the rubber. Never mind, he just hung it. Yeah, okay.
Yeah.
Yep. Nope.
That's not going to work.
Hey, but he's got inverted subs and a cap.
It makes them louder, right, Joe? Yeah, look at this
Makes
wire
the THD
mess.
louder.
Oh my gosh, it's just a mucky.
Yeah, but it's got bass, man. I understand. I was a bass head when I was a kid. I can feel him.
Yeah, we've all started somewhere, man. Yeah, that's just, you slam on the brakes and you're going to have a fire. I didn't even see a fuse up at the front of that. I forgot to look.
There's a big
Oh, was there a
block on the
fuse?
side,
Okay.
yeah.
Okay, so yeah, so there's the fail fun of the week. Now I want to show you a couple of cool picks. Now, I did mention earlier that I was in Indonesia on vacation, and I want to share with you a couple of pictures, not too many, just a few pictures of my vacation, because I had a great time, and I just want to share with you a little bit. So now I traveled with my wife and 7-year-old daughter, and this is our luggage. Now, I could have traveled with this, but they needed all this, plus backpacks. So yeah, we travel heavy. The porter hated us. So I got a snack on the plane, because we took a lot of airplanes to get there and to get around Indonesia. And I just thought this was funny. Because you matter, mixed nuts. Because you matter, sanitizing wipe. Huh. Strange, right, Joe? Strange.
You
Moving
matter,
on.
Aaron.
So Indonesia makes some great coffee. I was at the coffee walk, and there was probably 10 coffee carts and coffee shops within, 100 yards. And so I had a lot of good coffee, and I had to share that with you. So that's my coffee stance. Next, we did some island hopping. We actually went to Komodo. You've heard of Komodo dragons? Yeah, we did see some Komodo dragons, which I'm going to show you in just a minute. But boy, was it beautiful there. So we're taking an island tour with a guide, and the guide spoke pretty good English. We're walking along this path, and he points and he says, "Don't touch that, it's dangerous." This is a massive spider, as big as my head. And you can barely see it, but the guide, thank God, he saw it, and that thing was terrifying. So then we come around the corner and we see this. This, my friends, is a Komodo dragon. It looks like a log laying on the beach. It is not a log. I'm going to show you the close-up. That is a close-up of a Komodo dragon. It's not dead, it's not a statue. So our guide, he doesn't have a pistol, doesn't have a rifle, he has a big stick. And he simply draws a line in the sand and he says, don't step over that and you'll be fine. So, of course, what did I do? Put my foot over that just to test it. So yeah, that's a Komodo dragon. These things are huge. And if you Google it, it's a terrible way to die. So we headed back to the home base. It was about 8 hours on the water. It was a great day. Good times. Then I went to my version of Crazy Rich Asian Wedding. So you'll notice these are all my cousins. Literally, these are all my cousins by birth, and I'm the only Caucasian dude in the space. What did you say earlier?
Well, you look really like a very happy tax accountant for him.
But this, so my wife's cousin was getting married, and this was a crazy wedding. This is a replica of a tornado, and that was the nod to the fact that the groom, right here, the other white dude in the room, he is from Oklahoma. And so this is my wife's cousin right here. And so we had 3 of these massive tornadoes behind the stage giving us the center point. And that was my Crazy Rich Asian wedding experience. So there you have it. I had a great time. Glad I'm back. So let's see, where are we now? We got pics. Oh yeah, some more cool pics. I want to show you. Ernie always gets some great stuff. Check out this ride here. I think, Joe, is this a smart car? Is that what that is? It looks like a
maybe
kind of an upscale smart car, but it's
that,
in
that
Greece.
could be a European electric car. Yeah.
Okay, so it's a Grecian car. So check this out. I want to say those are 415s. Yeah, there we go, 415s, and it looks like Cadence amplifiers. Not sure why they chose Cadence. Now, are these mids? Are these like 12-inch mids?
That's your dash mid bass, baby.
That's what that is.
It gets you the bass on the dash. You don't
Yes,
have to worry about time alignment a whole lot. You don't do anything. You just get the bass up front.
And then you've got your bullet tweeters. So yeah, I bet this thing screams at you. So yeah, that's cool.
That's a lot of fabrication work.
Yeah, well, man, they obviously spent a lot of money on this and time. But that's a cool install. And then there's our 415s. Comp Rs. So nice, very nice install. Thank you, Ernie, for pulling that up for us. So let's see, upcoming events. Father's Day, right, Joe? Joe's a father.
Yep.
I'm a father. Father's Day is coming up. And in honor of Father's Day, I happen to have a book of dad jokes. I was out shopping with the family, Typo Market, downtown Stillwater, came across a book of dad jokes. And I'm going to read to you a dad joke for Father's Day. So here we go. Some people like elevators, some like escalators. Depends on how they were raised.
You done messed up, Aaron!
Oh, this is going to be long.
You done messed up,
One more. So my favorite out of this book, my favorite one that I've read so far was, did you hear about the 45-cent concert that's coming up? We're having a 45-cent concert here in Stillwater. You know who's playing? I'll tell you who's playing. 50 Cent and Nickelback. That's good stuff.
Must be getting late, right?
So there we go. Let's pick out some winners. Oh wait, no, one more thing. Skills USA. Skills USA is coming up. Jacob and I are headed to Atlanta for the Skills USA National Competition. Brian Gary, the Skills USA National Competition. What? Oh, I'm sorry. I'm getting too excited. Okay, sorry. Microphone shutting down. So Brian Gary's going to be there. He's helping us judge, and he's now tech chair, co-tech chair, and of course Chris Jack's going to be there. And we're going to be out there with, I think we've got 15 or 18 competitors in mobile electronics installation competition this year. So we're very excited about that. If you're in the area, Atlanta, June 24 to 26. Stop by. It's a great competition. It's a huge convention center, and there's a lot of other competitions going on, 115 competitions to be exact. So that's going to be a good time. So that's coming up quick, and then of course we'll have a recap about that event with a lot of great pictures afterwards. So there's the events that are coming up. Now, prizes. Who's our third place prize? Third place prize winner is Rodolfo L. from Texas. Congratulations, you're the third place prize winner. You get the TW1 True Wireless 1 earbuds. You get a couple of koozies and of course the Unmasked t-shirt. Winner number 2, who's that tonight? Winner number 2, Caleb P. from North Carolina. Congratulations, Caleb. You get the TW2s, which is the upgraded. You also get the 2 koozies and of course the t-shirt. And winner number 1, Randy S. from Florida. Congratulations, Randy S. from Florida. First place, you get the Bullfrog, the 2 koozies, and of course, the t-shirt. Oh wait, so we've got a dad joke from Bambro. Why do seagulls fly over the sea? Because if they flew over the bay, they'd be bagels. Bagels.
No, pretty good.
Bagels, love it. Good one, good job. He's also a father. Steven's also a father. He has raised some very nice young gentlemen, so he's done a great job. Friends, Andy does not have the strength of internet required to run a show tonight, so no Andy after show. So just, go home and relax and chill out and, maybe go to bed early tonight. But our next Unmasked show is June 24th. So June 24th is the next Unmasked show. And Joe, any final thoughts?
No.
Nothing?
No.
Okay. Friends and
run
neighbors?
extra power wire, run extra batteries, please.
Okay.
Make sure your ground's good.
And for Father's Day, dads need extra power wire and extra lithium batteries, right?
I think they need a 3601 and some horror solo X's. That's what I think they need.
That's what your dad needs.
That's what your dad needs.
So there you
see
go.
the memes where they say, ask the wife before you go to the car. That's what you gotta do.
But it's Father's Day. It doesn't matter.
Yeah, you get a
Just
freebie.
go. Gift for yourself. All right, friends, thanks for being here tonight, and we will see you on the 24th of June. Good night.
Feel the rush at your feet. Tear the night with electric scream. Amped up dreams fuel the stream. Thunder blast through endless skies. Driving forward never dies.